Okay, so we're going to go over factoring x squared plus bx plus c in that format. This is factoring our trinomials with a leading coefficient of 1. So our a equals 1 in our format of ax squared plus bx plus c. So when we're factoring these trinomials, our first step is to check to see if there is a greatest common factor, a GCF, that can be factored out of the trinomial. So that's step 1. Step 2 is we're going to find two factors or two integers with a product of C and the sum of B, which I already have written in there. Oops. So we want the product of C and the sum of B. The product of C and the sum of B. And these are going to be what we use to figure out what our factors are. They will be our factors. So let's look at the first problem. We have x squared plus 9x plus 20. So our leading coefficient is 1. We do not have a greatest common factor. So we want two factors that have a product of 20 and a sum of 9. That's what we're looking for. So factors that make 20 and add up to equal 9. So what are the factors of 20? We have 1 and 20, 2 and 10, and 3, no, 4 and 5. So those are our factors. So what do they add up to? Well, 1 plus 20 is 21, 2 plus 10 is 12, and 4 plus 5 is 9. So the factors are going to be our 4 and our 5. So that's x plus 4 and x plus 5. So those are our factors. When we're dealing with a leading coefficient of 1 in our trinomial, whatever we can find that it is the product of our C and the sum of our B, that is what we're working with as far as factors. Now, you might be wondering, how do I check to see if this is correct? What you do is you multiply your answers, your factors. You can use either the FOIL method or the regrouping method that we talked about during multiplying trinomials. And if it equals what we were given, then you know it's correct. Okay, so there is some other scenarios. And it says at times there are no factors with a C with a sum. I don't know why it's doing this. A sum of B. So sometimes it's not possible. And when that happens, the polynomial cannot be factored and is a prime trinomial. If you remember, prime numbers are the numbers that can only be multiplied to get to by 1 in itself. So like 1, 2, 3, 7, 5, 7, numbers like that are prime numbers. So it's kind of like that. It can't be factored anymore. So we're going to look at these 3 problems. One to practice our factoring, and one of them will be a prime trinomial. So we're going to figure out which one that is. So looking at 6, do we have a greatest common factor? No. So I'm going to make my little T-chart here. I want a product of 14 and a sum of -9. Now, I know that my answer, my sum here is a negative. That only happens if I have a negative in one of my factors. But because my product is positive, that means that both of my factors will be negative, because a negative times a negative equals a positive. So the factors of 14, we have 1 and 14, we have 2 and 7. Now, like I said, we talked about the negative, so those are going to be all negatives. A -1 minus 14 is -15. -2 minus 7 is -9. So our factors are those. So that would be x minus 2 and x minus 7 as our factors. Now, a couple of kids have asked me before, Miss, is it always going to be the bottom ones? No, it does not have to always be the bottom ones. When we're doing these practice documents and we try to use the smaller numbers, just because the smaller numbers are easier to work with. So it's just kind of a coincidence that it keeps ending up being the bottom number. So it does not have to be the bottom one or the last two factors. It can be any of them on the list. Okay, looking at number 7. Is there a product of 1 that is a sum of -5? Is that possible? Well, no. So this is not factorable. So it's a prime trinomial. And that's because there's nothing we can multiply. One is a prime number, so 1 times 1 is our only options, and there's no way that we can make 1 and a 1 equal a -5 as our sum. So that is not factorable. Let's go look at number 8. We have b squared minus b minus 30. So we need, in our t-chart, let's go see if we can make that work for us. I need a sum of -1 and a product of -30. Well, now my product's negative, so that means only one of my factors is going to be negative. But my sum is negative, so that means my bigger factor is going to be the -1 because we're going to end in negative, so I need more negative than positive. So let's look at our possible factors of 30. We have 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And our bigger numbers were our negatives because we wanted, and only one factor is negative because we have a product that's negative and our sum is negative. So we need the bigger number to be negative. So 1 minus 30 is -29, -13, -7, -1. Once again, this is going to be our factors. So we have x plus 5 and x minus 6. Okay, so that is factoring trinomials with a leading coefficient of 1. But we may not always have a leading coefficient of 1. So let's talk about the scenarios when we have a that equals any other number. It could be any other number than 1. So our factoring checklist, kind of the steps that we're going to go over. First, is there a greatest common factor that can be factored out? If that's the case, that's our first step. So looking at this problem, or this example problem, each one of our coefficients is even. So I know that I can at least pull out a 2. And my c is not a constant. There's not an x there. So that means I don't have a variable I can take out. So my greatest common factor is 2. Divide 2 by each of the terms or into each of the terms. Left with x squared minus plus 7x plus 10. So now our question is the polynomial in the form x squared really is our leading coefficient 1, or is it more than 1? That's what we're asking. If it's more than 1, we have extra steps to do, but right now it's just 1. So we would solve it just like how we did on the last page. Find a t-chart. We want a product of 10 and a sum of 7. They're both positive. So 1 and 10 and 2 and 5. That's 11, that's 7. So our factors are 2 and 5. So writing that out, that'd be 2x plus 2 and x plus 5. So those are factors for 2x squared plus 14x plus 20. So what to do if we come across a scenario where a is not equal to 1? It's something else. What we're going to do is we're going to factor by grouping, or also known as the AC method. That's what we're working on, is what the method is called. If you remember when we were talking about multiplying polynomials, we talked about a method of grouping. And that's kind of the same thing that we're doing here, but going backwards, because factoring is going backwards. So our first step is going to be find two integers whose sum is b, that hasn't changed, and whose product is a times c. So it's not just the product of c, it's the product of a times c. So that is where it changes for us. Once you do that, we're going to rewrite the middle terms using the integers in step 1. We're rewriting whatever our two integers that we find in for step 1. We're going to rewrite the b term, the middle term, using those integers. We're going to group to create two pairs. We're going to find the greatest common factor, and then we're going to rewrite the factors. I will tell you, when you're working in step 2 and you're rewriting these, you're going to want to keep these steps in mind, as well, specifically step 3 and 4. So when you're trying to group and you're rewriting the middle terms, you're going to want to keep steps 3 and 4 in mind, kind of thinking ahead. So let's get started on a practice example. Okay, step 1, do we have a greatest common factor? No, there is nothing that we can take out of each term. So the step 2, or question 2, when we're in our factoring checklist, is it in the form of x squared plus bx plus c? Do we have a leading coefficient of 1? The answer is no. So now we have to factor by grouping, or this AC method. You can also use your algebra tiles. Please make sure, if you're using algebra tiles to help you understand this, that you let your teacher know, either myself or Miss Reyes, that is an accommodation we can help you get on the EOC test at the end of the year. So if you're really using them and they're really helping you, please communicate that with us. Please let us know what days you're using it, what assignments you're using them on, and we can get that to help you on the exam at the end of the year. Okay, so we need factors that are the sum of 8 and the product of 3 times 15. Well, 3 times 15, I'm sorry, 3 times 5. I'm skipping ahead. 3 times 5, well, that equals 15. So our little chart over here, to give us space, I want a product of 15 that adds together to be 8. And we have 1 and 15 and 3 and 5. Well, you can see that it's going to be the numbers that we started off with, but that is not always the case. That is not always the case. So when we are factoring by the leading coefficient of 1 trinomials, this was where we had our answer. But when we have a leading coefficient that is not 1, this is not our answer. This is just the first step into finding our factors. So these are our two integers, 3 and 5, that we're going to have to rewrite. And remember, I said to look ahead, know that we're going to have to find a greatest common factor when you're rewriting in step 2 to rewrite the middle term. So what we're doing is we're taking this b term and we're rewriting it with our integers. Remember that it's going to have the x there. That hasn't gone away. If you remember when we were multiplying our polynomials, we ended up with these two terms and we had to combine like terms. We're doing the exact opposite of that. We're going backwards. We're breaking up those like terms. And x was our variable for both of those. So do not forget your x. But I have 3 and 5. Well, I know that I'm going to be needing to group and pull out a greatest common factor. So I'm going to write my 3 over here by a 3, because I know that I can pull 3 out, plus 5x, and I can pull there. So our next step, that's step 2. Step 3 is using grouping to create two pairs. So what I'm going to look at is I'm going to look at this pair and this pair. Okay, greatest common factor. What's the greatest common factor between 3x squared plus 3x? Well, I know I can get a 3 out and I can get an x out. So I'm going to divide both of those. by 3x. Well, 3x squared divided by 3x is x plus 1. Now I'm going to look at, well, I may not, it should be a positive. When I look to find my greatest common factor for the second group, or even earlier when you're looking at rewriting this, not only are we pulling out a greatest common factor, but we want the greatest common factor to match what was left after we took this one out. We want it to match that x plus 1. So looking at our second group, we have 5x plus 5. I have a greatest common factor of positive 5. I'm going to take that out. 5 divided by 5x divided by 5 is x, and 5 divided by 5 is 1. So see how those match? This is where, when we were multiplying polynomials, we took the first binomial and split it up and multiplied it to the second one. That's where this is that grouping method. So our two factors, we're going to rewrite. We did step 4. We're going to rewrite the factors now. So our factors are 3x plus 5 and x plus 1. So we are rewriting, we took out our greatest common factor, our remaining matches, and so those are our two factors, what was left and what's the greatest common factors. You kind of combine those greatest common factors. Okay, let's do some practice because I know that's probably a little confusing. So 6x squared minus 11x plus 3. Is there a greatest common factor? No, there's not a greatest common factor there. So we got to look at question 2. Is it in the form x squared? Nope, we have an a that is greater than 1. So we're going to have to follow these steps for grouping. So we need a sum of negative 11 and a product of 6 times 3, which is equal to 18. So our product is positive, but our sum is negative. So that means both of our factors are going to be negative. Because a negative times a negative is positive, I need a positive 18 and a sum of negative 11. So what do I have? Let's see. 1 and 18. Giving myself a little bit more room to go back and put negative signs in. 1 and 18, 2 and 9, 3 and 6, 4 no, and 5 no. So they're all going to be negative because a negative times a negative is the only way I can get a positive here and a negative there. So 1 minus negative 1 minus 18 is negative 19. That's supposed to be negative 11, negative 9. So our integers we're working with are x minus 2 and, I'm sorry, not x minus 2, negative 2 and negative 9. So I'm going to rewrite this. We're going to rewrite that middle term, 6x squared. We're going to have a blank and a blank plus 3. Okay, now this is where we have to get a little specific. If we're doing negative 2 and negative 9, which ones are we going to write with 6? The 2 and the 9 both have a common factor with 6. But when we look at 3, 2 and 3 do not have a greatest common factor that we can pull out of that. So I know that the 2 is going to have to go with the 6 minus 2. Don't forget the x minus 9x. Remember, I'm getting the x because if we combine those like terms of negative 2x minus 9x, we still get that x. Okay, now we're going to group. Look at the two groups. Greatest common factor of 6x squared and negative 2x. So I'm going to pull out, there's an x and they're both even, so I can do a 2x. I'm going to divide that. That's going to be 3x minus 1. Okay, now I'm going to look at the second one, the second group. Remember, I want to match that term. I want to match that term. So I need to pull out a number that's going to make a positive 3x and a negative 1. So if I'm getting a negative 9x and I want a positive 3x, then that means I need to pull out a negative 3. If I pull out a negative 3, negative 9x divided by negative 3 leaves me with a positive 3x. Positive 3 divided by negative 3 leaves me with a negative 1. So now these two terms match. Those binomials match. I rewrite my factors. 3x minus 1. So those are our factors. Remember, if you're confused, like maybe you're not sure or you don't trust that this is your answer, you can always go through and multiply these polynomials, these binomials, using either the FOIL method or the grouping method, or using algebra tiles to make sure you get the answer that we started with. Okay, one more practice problem. 2, -5, and -12. Well, no greatest common factor. We have a leading coefficient that's not 1. So once again, we're going to have to use our grouping or AC method. So table. I need a product of 2 times -12, that's -24, and a sum of -5. Why is it doing that? -5. Okay, so if I have a product that's negative, that means one of my factors is negative. Because my sum is negative, that means I have more negative than I have positive, meaning my bigger number is negative. So let's talk about factors of 24. We have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Remember, my bigger number is negative. Okay. 1 minus 24 is -23. 2 minus 12 is -10. 3 minus 8, -5. And -2. So 3 and -8 are my integers that I'm going to use to rewrite. So once again, we've got 2k squared. We have 2 blanks minus 12. So if we're looking at 3 and -8, 3 does not have a common factor with 2. So I know that -8 is going to go there. Don't forget your variable. And that's a positive 3. So plus 3k. Group. All right. What is our greatest common factor? Well, 2 can go into both of them, and they both have a k. So we have 2k coming out. 2k squared divided by 2k leaves me with k minus 4. And then looking at 3k minus 12, I want to end up with a k minus 4. So that's going to be real simple. I'm just going to divide by 3. So plus 3 is my greatest common factor, k minus 4. Our terms match there, so I can rewrite my factors. Plus 3 and k minus 4. Okay, that is factoring our polynomials or trinomials using either, or looking at either scenario of a leading coefficient of 1 or a leading coefficient of anything but 1. Please remember that when you're finding these factors on the leading coefficient that's not 1, when you find your answer in the table, that's not the factors. You have to go in and rewrite, group, and then find your factors.